All right, so for this deep dive, we're unpacking a piece of practical environmental monitoring tech. It's all about getting that immediate critical knowledge when things go wrong. We're looking at the NTI E-ALDS addressable leak detection sensor.
Right.
And if you've ever had to hunt for a tiny puddle on a huge data center floor, well, this is kind of like the GPS coordinate you wish you had.
Exactly. And our mission today really is to see how this system goes beyond a simple, leak detected alarm.
Right, the blinking red light.
Yeah, that just causes panic. This gives you precise location data. And that specificity is so crucial because it can turn, minutes of frantic searching into just seconds of fixing the actual problem.
So this is way more than just a basic flood sensor. And this, I think, is where it gets really interesting. The EALDS doesn't just monitor for liquid.
Mhm.
It turns, thousands of feet of cable into a super specific coordinate system. It doesn't just say you have a leak. It tells you exactly where that leak is.
And what's fascinating to me is how it almost acts like a crisis manager. It finds the specific spot, yes, but it also prioritizes for you.
Prioritizes. How so?
Well, if you get multiple leaks at the same time, it reports the location of the one that's closest to the main control unit first. It's basically performing triage on the emergency.
Ah, okay.
Then, once you clear that first one, the system just cycles through and reports the next most critical spot and so on until everything is dry. You're getting knowledge you can actually act on in the right order.
Triage is the perfect word for that. Okay, so a huge coverage area is great. But what about the accuracy? How does it maintain that pinpoint precision across, potentially thousands of feet of this cable?
The scale is pretty massive. You can have up to 4,000 feet of this location-aware sensing cable.
4,000 feet.
And you can even extend the range between sensitive zones with non-sensing cable. But the accuracy holds up remarkably well. For shorter runs, say up to 1,500 feet, it knows the location to within a foot or two. And even when you push it all the way out to that 4,000-foot maximum, it's still accurate to within just 1% of the total length. That's impressive fidelity over that kind of distance.
That kind of precision is exactly what you need when the clock is ticking. So how does that information, get from the subfloor into the main system so someone can see it?
It's actually pretty simple. It connects using standard network cabling, like a CT5 or CT6, right into the main NTI control hub, just a simple sensor port. And because it's a safety system, it has a really crucial built-in safeguard.
Ah, the self-check feature. Yeah, that's vital. How do you know the system itself hasn't failed while it's just sitting there waiting for a leak?
Correct. The system is always checking itself for breaks or compromises in the cable. It comes with this little plug, a terminator.
Okay.
And that has to be plugged into the very end of the cable. If it's not there, if the cable gets cut somewhere, the system automatically registers a circuit break.
And it tells you right away.
Immediately. You get an alert from a built-in piezo buzzer. And it's loud. We're talking 70 decibels. So even in a noisy server room, you're going to hear it. It confirms your monitoring system is armed and ready.
So when you boil it all down, the EALDS really just takes the guesswork right out of the crisis. It's high precision, it's scalable, and it actively manages the emergency by telling you what's most important first.
And if you connect that to the bigger picture, it really highlights this fundamental shift we're seeing. We're moving from just passive observation, a simple alarm, to active, addressed data delivery. It's about using tech to do that emergency triage for you instantly. And that, I think, raises a really important question for anyone listening. When that information is critical to preventing downtime, how much precision are you willing to invest in for that very first point of detection?